This video is on independent and dependent events, so we're going to look at independent events first. Two events are independent if the occurrence of each event does not affect the occurrence of the other. Now, if two events are independent, then we can use this rule, that the probability of A and B is equal to the probability of A times by the probability of B. Now, something we have to note is that we can never assume independence. If unsure, use the addition law of probability from the previous video, and you will get the right answer if you use that rule. This one, we can only really use it if we definitely know they are independent. So first example, a 4-sided die and a 6-sided die are rolled simultaneously. Find the probability that both numbers rolled will be greater than 1. Now with this, we know the events are independent because rolling the 4-sided die does not affect the rolling of the 6-sided die. So the outcomes of rolling each die do not affect the outcome of the other one. Therefore, they are independent. And we want to find the probability that both numbers rolled will be greater than 1. Probability that both are greater than 1. So which means we want the probability that the 4-sided is greater than 1 multiplied by the probability that the 6-sided is greater than 1. Now the probability on a 4-sided die that it's greater than 1 is going to be 3 out of 4 because you're going to have got numbers 1, 2, 3 and 4. So the greater than 1, we've got 3 out of the 4 numbers are greater than 1. And on a 6-sided die, we would have 5 out of the 6 numbers is greater than 1. Multiply those together, and we'll get 15 over 24, which simplifies down to 5 over 8. Example 2, a marble is selected at random from each of the bags. As you can see here, we've got bag A and bag B. Draw a tree diagram to display the possible outcomes. Now we're going to start with bag A first with our tree diagram, and in there we've got two colours, green and yellow. So we've got green and yellow. Then we're going to have bag B, which has got three colours, green, yellow and orange. So green, yellow and orange, green, yellow and orange. When we draw a tree diagram, we're then going to do our outcomes. So this top one, if we went here and then here, we have green, green. The next one would be if we went green and then across to here, so it'd be green, yellow, and then green, orange. And if we got a yellow first, we could have yellow, green, yellow, yellow, or yellow, orange. With this, we can also put probabilities in our diagrams because we know how many marbles are in each bag. So in bag A, green and yellow, there's 3 greens and 2 yellows, which is 5 in total. So there'll be 3 out of 5 for green, with the probability of getting a green, and 2 out of 5 will be the probability of getting a yellow. Now with bag B, we've got 7 marbles in total. Now we've got 4 greens, so in bag B, you could have 4 out of 7. The yellow would be 1 out of 7, and the orange 2 out of 7, because there's 2 oranges in the bag. And because each bag is separate, they're independent of each other, they don't affect each other, so the probabilities are not going to change if we picked a yellow out of bag A first. That's our tree diagram. Then part B, find the probability of obtaining a green marble and a yellow marble. So green and a yellow, we have this one and this one. These are our two options. When we're working with the tree diagram and probabilities, and we are working across a tree diagram, we always multiply. So for the green yellow, this would be 3/5 for the green multiplied by 1 over 7 for the yellow. The yellow green, we have to go down the yellow pathway first, which is 2 over 5, multiplied by a green there, which is 4 out of 7. So when we're working across a tree diagram, we always multiply. And then we have those two and we just add them together. And so then when we're working down with these probabilities here, we add. So going across, we multiply our probabilities. Working downwards, we add them together. So with this one here, part B, so we want the probability of green and yellow, which is going to equal our 3/5 times 1 over 7 plus 2/5 times 4 over 7. And if you work that out in your calculator, you'll get an answer of 11 out of 35. Next, we have dependent events. So a dependent event is where the occurrence of one event does affect the occurrence of another. Now, if A and B are dependents, then we've got this quick rule, which is the probability of A multiplied by the probability that the B, given we know that A has occurred. So first example, a fruit bowl contains 3 apples and 5 oranges. Callan selects a piece of fruit and eats it. Michelle then selects a piece of fruit. Find the probability that 2 apples are selected, and then B, Callan selects an orange and Michelle an apple. So with this, I'm going to draw a tree diagram because it's the easiest way to represent this information. Callan, and he selects a piece of fruit. So when he selects a piece of fruit, we've got apples and oranges. An apple is, there's 3 apples out of the 8 pieces of fruit, and there's 5 oranges out of the 8. Now, when Michelle goes to select her piece of fruit, if Callan has selected an apple first, that means there's 1 less apple in the bowl because he's eaten it, which means we now have 2 apples left out of 7 in the bowl. Because if Callan's already taken a piece of fruit out, it means there are now only 7 left. If you took an apple, there are only 2 apples left, and we would still have 5 oranges left in the bowl. Now, if Callan selected an orange first, we'd still have 3 apples, but we now only have 7 in the bowl. And if you selected an orange first, then we'd only have 4 oranges left out of the 7 pieces of fruit left in the bowl. So then our possible options would be an apple, 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 orange, orange, apple, or orange, orange. Now we can work out our answers. So for A, we want 2 apples are selected. So that's just going to be this first one here. So we want the probability of apple, apple, which would equal 3 out of 8. Remember, we multiply across, so 3 out of 8 times by 2/7, which will give us 6 out of 56, which simplifies down to 3 out of 28. Then part B, Callan selects an orange and Michelle selects an apple. So it's on orange and apple, which will be this one here that I've just circled in purple. So a probability of orange, then an apple, which will be 5 out of 8 for the orange, multiplied by 3 out of 7 for the apple. And we'll this time get 15 out of 56. And that is dependent events.